Hey everyone, I'm Tony. Today, my team member Flex and I will show the combustion experiment we explored these days. The topic is whether the ferric oxide will affect the combustion of solid rocket fuel. This is the poster of our group. With a total of 6 pages, we will display the content of the poster in the following videos.
We chose this topic because it is novel, and no one has done this experiment before. We don't want to study how to do the experiment by others and have a clean answer before the experiment. In this experiment, we can explore how the catalyst affects the combustion of fume, and why the catalyst will affect the changing. We think when we add a catalyst to the fume, the rate of rocket fume burns and the maximum thrust will increase, because the catalyst can help fume to decrease the oxygen damage. The lower air damage, the more appropriate the chemical combustion is and the more energy is produced. In experiment, the fume of rocket is made by sugar and makes the potassium nitrate serving and sucrose. This propellant is usually called KNSU. It's a rocket fume that's safer than others. KNSU is 65% potassium nitrate and 35% sucrose, a ratio that provides optimal performance. Most experimentally perfume a ratio of 65 divided by 35. There are 3 reasons. First, the propellant catalyzation data has been obtained mainly for the 65 divided by 35 ratio. Second, the performance difference is insignificant, about 1%. Third, with the increase of OF ratio, the combustion temperature rises separately. At a ratio of 65 divided by 35, the straight nozzle is not damaged, but at the higher ratio, the increase in temperature will melt the nozzle. Our controlled variable is we need to make sure the quality of potassium nitrate and the sorbitol is in phase. Also, we need to make sure the volume quality is the same before the experiment. We must make sure the solid volume ratio is the same every time. The combustion of the solid rocket made by our experiment contains potassium nitrate and sorbitol, so we have to make sure that their ratio and quality are the same. The next part is variable. Our independent variable is add catalyst into solid rocket fume. Because our experiment topic is to explore the effect of catalyst on solid fume combustion, we need to divide the experiment into 2 groups. The first group of solid fume does not require catalyst addition, and the second group of solid fume requires addition of catalyst. Our dependent value is the burning rate and the thrust produced by solid rocket of the same mass and volume. Because the topic of our experiment is the effect of catalyst on combustion, so we predict that the catalyst affects the rate of combustion and the thrust produced by the solid-state rocket, which varies with the presence or absence of the catalyst.
This is the material we used for this experiment. There are electronic scales, ceramic bowls, spoons, tripods, 3 or 4 material steel pipes with an outer diameter of 2.5 cm, 3 or 4 material 19.5 mm threaded pagoda nozzles and nozzle diameter of 6 mm, 304 material 19.5 mm plug cap, sorbitol, ferric oxide, potassium nitrate, and a very important ignition tool, a windproof lighter. Next, we put a piece of toilet paper on the surface of the electronic scales to prevent contamination of the equipment when weighing powdery solids. Then we use a spoon to weigh the right amount of sorbitol powder and put them on the electronic scale. We first weigh 9 grams of sorbitol powder. By calculation, I found that 9 grams of sorbitol would not make enough fuel to fill the rocket, so I increased the sorbitol content to 10.5 grams. Next, we poured the sorbitol powder from the toilet paper into a ceramic bowl. Next, we use a spoon to weigh the mass of potassium nitrate. The optimal ratio of KNSU fuel is 3.5 or 6.5, so we weigh 19.5 grams of potassium nitrate. If you want to make KNSU fuel with ferric oxide added, you should add 1 grams of ferric oxide powder to the mass of sorbitol and potassium nitrate just now. Next, we mix sorbitol and potassium nitrate, put a treadle on the gas stove, and put the ceramic bowl with sorbitol on the treadle and turn on the fire. We wait for the sorbitol to melt. The sorbitol melted immediately as the temperature increased, and it only took half of a minute. When the sorbitol is completely melted and turns light yellow, we turn off the fire and clamp the bowl to the side to cool down, so as to prevent the temperature from reaching the ignition point when potassium nitrate is added. When the sorbitol becomes slightly viscous, we add the previously prepared potassium nitrate powder. Stir quickly with a spoon and use the residual temperature of the sorbitol to mix it. Next, we use a spoon to add KNSU fuel into the fuel tank of the rocket. If the fuel is found to be insufficient, we need to make some more fuel until the height of the fuel is equal to the highest point of the steel pipe. After that, we're going to screw the nozzle really tight because the reaction is very violent when the fuel burns. And we have to stuff a strip of toilet paper over the nozzle of the rocket because KNSU fuel gets wet easily. We weighed the rocket filled with fuel and the mass was 136.5 grams. We had to control the rocket in the 6 experiments to be of this mass. Next, we make the fuse from the remaining KNSU fuel. We hand roll the fuel into long strips so we can stuff it into a rocket nozzle with a small inner diameter. Next is the last part of the rocket engine. A hole is punched in the cold rocket fuel, which can make the fuel burn more fully and quickly. Finally, we plug in the previously made fuse and the rocket engine is finished. Before ignition, we need to fix the rocket engine in one place with a heavy object because the thrust will be generated when the fuel burns, and if it is not fixed, it will cause the engine to fly randomly and cause an accident. This is KNSU fuel with ferric oxide. This is KNSU fuel without ferric oxide. The table in front of us shows the data of our 6 experiments. We not only recorded the time required for the KNSU fuel in the fuel tank to burn out, but also recorded the time required for the fuels to burn out. We found that the KNSU fuel containing ferric oxide and the burnout time of the fuels were generally faster than the KNSU fuel. The average of KNSU solid fuel combustion time is 32 seconds, and the average of KNSU plus ferric oxide solid fuel combustion time is 23 seconds. And in addition, the average time required for KNSU fuels to burn to completion requires 19 seconds, and the average time required for KNSU plus ferric oxide fuels to burn to completion needs 9 seconds. Overall, at solid content of 28 grams, the KNSU fuel containing ferric oxide burns an average of 9 seconds faster than the KNSU fuel without ferric oxide. Moreover, when the length of the fuse is the same, the fuse containing ferric oxide is 10 seconds faster on average than the fuse not containing ferric oxide. So we can conclude that the ferric oxide will affect the burning speed of the solid fuel, and an appropriate amount of ferric oxide fuel can accelerate the burning speed of the solid fuel. Since the inner diameter of the rocket nozzle remains unchanged, the fuel with ferric oxide will generate greater thrust when burning. My experiments provide that my suspicions were correct. This is because for the same length of ignition wire, the average time required for the wire with ferric oxide to burn out is 9 seconds, whereas the average time required for the wire without catalyst to burn out is 19 seconds. There is a difference of 9 seconds there. Furthermore, for same mass of fuel, the average time to complete combustion the catalyst added fuel was 23 seconds and 32 seconds for non-catalyst added fuel. There's 9-second difference. This demonstrates that adding a ferric oxide catalyst can significantly improve the combustion rate of the solid fuel. This is exactly what I predicted prior to the experiment. Because the ignition method we used during the experiment is to use the KNSU fuel twisted into long strips to ignite the KNSU fuel in the rocket fuel compartment. And the rocket we used is made of 304 stainless steel. It is difficult to judge with the eye whether the fuel in compartment has started to burn, and we can only judge whether the KNSU fuel in the fuel tank has started to burn by hearing the sound. So we cannot know the exact time when it starts to burn. There will be some errors in the estimation method. We know from our experiments that ferric oxide is a solid fuel catalyst that can effectively increase the burning speed of fuel and rocket thrust. In the future, I believe we can investigate the effect of different catalysts on rocket combustion and which type of catalyst can provide the most assistance to solid fuel combustion. Second, at a higher level, I believe we can investigate how different rocket motor shapes and size affect the rocket thrust. This is our reference page. Thank you for watching.